Hi there, welcome back to Organic Chemistry. I want to take a few minutes and just quickly take up the homework from last night before we move on to a short note for today. All right, so yesterday I left you with, on Friday, I left you with these 4 questions for homework. And they're basically, the first 4 are naming compounds that are alkanes, right? Carbon-carbon single bonds only. So again, notice for the first one here, I've got 3 carbons joined by single bonds, and then hydrogens for all the rest of the carbons. So if I go back to my periodic table, which I haven't got up right now, you'll see that 3 carbons is propane. So my first molecule here is propane, 3 carbons. If I look at number 3 there, beside that, I'm seeing 1, 2, 3, 4, 5 carbons. Notice that the end carbon has 3 hydrogens, like this end carbon has 3 hydrogens. The second carbon has 2 hydrogens, the end one has 3. So all the ones that are in the middle of a chain, the carbons can only have 2 hydrogens because they're already using 2 bonds to connect with the carbon on each side, which leaves 2 electrons for carbon. Remember, carbon has 4 valence electrons, which means 4 bonds. So it's going to form 2 bonds to carbon and 2 bonds to the remaining hydrogens. So this molecule here that has 1, 2, 3, 4, 5 carbons, again, go back to your periodic table, or maybe you're just remembering already that 5 carbons means pentane. Boy, I wish this stylus was working a little better tonight. Pentane. Now, if I look at the molecule number 2 down here, I'm seeing that I've got 1, 2, 3, 4, 5, 6 carbons in a chain. Let's ignore that carbon that's on top for a minute. So the 6 carbons in a chain make it hexane. So I'm going to start by naming my parent compound called hexane. And now I've got to actually include that extra CH3 group, this one here. So if I look at where it is, count it from the end, I've got 1, 2, 3, 4 carbons. So it would be on the 4th carbon from this end. Or if I count from the other end, it's on the 1, 2, 3 carbon. So I'm going to count from the side which it is closer to. And notice that there's only 1 carbon in that side chain. 1 carbon is a methyl. All right, remember, meth means 1. So if I go back up here, notice that methyl here, methyl means 1 carbon, ethyl is 2 carbons, propyl is 3 carbons, butyl is 4 carbons. Just like methane is 1 carbon, ethane is 2, but if it's a side branch, we've changed the ending to YL. So it's methyl. So let's go back. So if I look at this molecule here, I'm seeing that I've got my 1, 2, 3, 4, 5, 6, and we decided on the 1, 2, 3 carbon from the end, I have a methyl group. So I'm going to make this 3 dash, because I'm switching from numbers to letters. 3-methyl hexane. 3-methyl hexane. Okay, there's no other way to draw that molecule. It has a 6-carbon hexane with a methyl group on the 3rd carbon of the hexane. If I look at the other molecule for number 4, I'm seeing that I have a chain which is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, which makes it octane. And then, so I've named the 8 carbons that you see right there. Now I've got to add, there's a 2-carbon group. So 2 carbons means ethane, but it's a branch, so it's ethyl. So it's ethyl octane. Ethyl octane, one word. And I need to say, where is the ethyl group? It's on the 1, 2, 3, 4th from this end, or 1, 2, 3, 4, 5 from this end. I'm going to use the lower number. 4-ethyl octane. Again, notice that if I was to take this molecule and just flip it around, pull this around to this side, pull this around to this side, pull this group to the bottom, this would be on the 4th carbon from this end by just flipping it around. So it doesn't matter how I look at it, I just want to know that it's on the 4th carbon from the end. 4-ethyl octane. If I move up to the 4 questions down here, 5, 6, 7, 8. 5 is decane. Of course it is. It's the biggest one. So let's go to my whiteboard here and we'll draw decane. Right? Decane is going to have 10 carbons. Remember, the first carbon has 3 hydrogens. The second one and all the other ones in between, 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7 carbons, 8 carbons, 9 carbons, 10 carbons. There's decane. Again, remember, all the carbons along the chain have got 2 hydrogens, right? 2 hydrogens, 2 hydrogens, 2 hydrogens. That's supposed to be a 2. 2 hydrogens, except for the ones on the end, because they're only bonded to 1 carbon, means only 1 electron is being used. I need the other 3 electrons to be coupled to hydrogens. Same thing here. This carbon is coupled to carbon using 1 electron. It uses the other 3 for hydrogens. Right? So, decane. If I look at the second one, number 6 is 4-propyl octane. Whoops. 4-propyl octane. So when I see this molecule, I'm going to start with my octane, 8 carbons, and then I'm going to put on the 4th carbon from the end propyl, which is 3 carbons, right? Methane, ethane, propane. So propyl means a 3-carbon side chain. So let's go back. So 4-propyl octane. Octane is 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 carbons. I have a 4-propyl. So on the 4th carbon, there's my 4th carbon there. I'm going to put a 3-carbon branch, CH2, CH2, CH3. And now I'm going to fill in the hydrogens along the chain. Now notice that this first carbon here needs 3 hydrogens because it only has 1 bond to carbon. This carbon needs 2 hydrogens. This carbon needs 2 hydrogens. This carbon here already has 1 bond, 2 bonds, 3 bonds to carbons, so it only has 1 electron left. So I'm going to put a single hydrogen on here. It's not CH2, it's just CH. This carbon will be CH2. This carbon will be CH2. This carbon will be CH2. And the end carbon always CH3. Okay, so there is 4-propyl octane, which is number 6. Number 7 is 2-methyl nonane. Nonane is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbons makes nonane, and I have a 2-methyl. So on the second carbon, 1, 2, on this second carbon, I need to add a methyl group, CH3. Now, if I fill in the rest of my carbons, this carbon needs 3 hydrogens. This carbon only needs 1 hydrogen because it already has 1 bond, 2 bonds, 3 bonds to carbons. So it's got 1 electron left, which it's going to use for hydrogen. This carbon is H2. This carbon is H2. This carbon is H2. H2, 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 H3. 2-methyl nonane, right? 9-carbon chain, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and a methyl group, a 1-carbon group on the second carbon, 2-methyl nonane. And number 8 is 3-ethyl heptane. Heptane is 7. 1, 2, 3, 4, 5, 6, 7. There's my heptane. And I have a 3-ethyl. So I'm going to count from the end. 1, 2, 3. So on this carbon, I need to add an ethyl, which means I have to add a 2-carbon chain. There's my ethyl heptane, 3-ethyl heptane. Now I've got to put in my hydrogens. This carbon gets 3. This carbon gets 2. This carbon here already has 3 bonds, so it only needs 1 hydrogen. This one needs 2 hydrogens. 2 hydrogens. 2 hydrogens. 3 hydrogens. Okay, there becomes 3-ethyl heptane. So notice it takes a little bit of getting used to, but once you've done some of these, you realize they're not too bad. Now, if we look in our notes here, we're going to move from the alkanes to 2 new families of hydrocarbons. The only thing that's different about these new families is the fact that the first group are called alkenes because they contain at least 1 carbon-carbon double bond. Okay, you can see an example down here. There's a carbon-carbon double bond. The other group that we're going to look at today are called alkynes. So we have alkanes, alkenes, alkynes. Alkynes have got a carbon-carbon triple bond. I'll have an example here. There's none here, but I will do one for you in a moment. Okay, so the naming of these things is very similar to the alkanes. I'm going to have methane, ethane, propane, butane, pentane like before, except the endings will end with -ene if there's a double bond. Instead of -ane, it ends with -ene. So it's pretty simple. This molecule down here, right, has got 1, 2, 3, 4 carbons, which would make it butane. Oh, but there's a double bond in here, which makes it butene. This one here, 1, 2, 3, 4, it's got butane because it's got 4 carbons. Oh, but it's got a double bond, which makes it butene. Now, I've got a bit of a problem here, because if A is butene, and C is butene, and let me just scroll up here, and B here has 1, 2, 3, 4 carbons, it's also butene. So I've got 3 butenes here. Now notice that A and B are exactly the same, right? This one has got a double bond on the first carbon. This one has a double bond on what would be the first carbon. If I could just take this whole molecule and flip it around 180 degrees, notice that the C double bond C would be right here at the beginning. That means this molecule here is the same as this molecule here, and it's got an -ene after the 1 carbon. This is a totally different molecule, right? These two are the same, but this is different. This has got a double bond after the second carbon. And again, even though they look almost identical, in terms of the chemistry, in terms of biology, remember this is organic chemistry, right? Remember our original definition for organic chemistry are chemicals that are made in living organisms, and they are either within the organism or have just been made by the organism. Now, that being the case, the chemicals are very, very specific. So the difference between this molecule and this molecule in your body would be, one would be almost like a banana, where the other one is like a raspberry. Completely, entirely, totally different things, right? They're both fruit, right? But at the end of the day, they're nothing like each other. And how do they taste? Differently. How do they behave in your body? Differently. What are the vitamins and carbohydrates and water content difference between raspberries and bananas? Completely different things. The same thing here. This is totally different from this. So I need to be able to tell the person who's using these how these two molecules are different. And the way we do that is, again, by using our numbering system. So if I look at A and B here, A and B are both butene, except for A and B, they are but-1-ene, which means the ene, the double bond, is after the first carbon. That one and this one are both but-1-ene. This molecule here is actually got the double bond after the second carbon. So this molecule up here becomes but-2-ene. Right? That's what happens when I end up with a double bond, ene, after the second carbon. Right? So I can now have a way to name molecules that have double bonds based upon where the double bond is located in the molecule. Now this molecule up here that is hex-1-ene, if I was to draw that, I would draw 1, 2, 3, 4, 5, 6, means hex. I see 1-ene. 1-ene means I've got a double bond after the first carbon. Right, there's my double bond right there. And I have the rest are all single bonds. One here, one here, one here, one here. Again, notice I've put my bonds closer to the next carbon to leave room for my hydrogens. Now notice an important piece here is down here, this carbon has 3 hydrogens. This carbon has already 1 bond on this side and 2 bonds on this side. So there's 3 bonds already, which means 3 electrons. It only has 4, so it uses its 4th electron up here for the hydrogen. The same thing on this side. This carbon has 2 bonds on this side, which it's using to bond to C2. 1 electron being used to bond to C4, so that's 3 are being used. I've got 1 left over for a hydrogen, so there's only 1 H. So this carbon up here has 2 bonds going to carbon, so how many hydrogens should it have? It needs 2 hydrogens, right? Because the carbon needs to have 4 bonds. 2 of them to the next carbon and 2 to hydrogens. This next carbon only has 1 hydrogen, right? Because it's got 2 carbons, 2 bonds, 2 electrons being used to bond to the first carbon, 1 electron being used to bond to the next carbon, so it's got an electron left, it's going to bond to hydrogen. This one here, CH2. This one here, CH2. This one here, CH2. And then my terminal carbon on this side, CH3. Notice that the terminal carbon here wasn't CH3 because the carbon is using 2 of its electrons for that double bond. This is hex-1-ene. I'm seeing 1, 2, 3, 4, 5, 6 carbons, and I'm seeing the double bond is on the very first carbon, right? Hex-1-ene. All right, let's just move up. It says draw the following molecules: ethene, ethine, and it should be hex-2-ene. This is the old naming system. This is not the way we name things anymore, right? The 2 comes just before the ene. Now notice for ethene, there's ethene right there. Right? You think, well, why wouldn't I say eth-1-ene? Because really, there is no eth-2-ene. There's only one possibility, and that's if the carbon comes after the first, the double bond comes after the first carbon, because there's only one possibility. So you could say eth-1-ene, but really, there's no need. And again, remember, chemists are a bit lazy. Water isn't H2O1, right? We've decided, rather, if there's a 1, we're not going to write it. Here, if there's only one possibility, we're just not going to write it. So my ethene, again, notice this should be CH2. This should be CH2 2 also. So those two CH2s are CH2s because the carbons have got already got 2 bonds to the neighboring carbon, so it only needs 2 hydrogens. This carbon has 2 bonds to the neighboring carbon, so it needs 2 hydrogens. If I have ethyne, I have C and I have a triple bond to the next C. Eth, remember, means 2. Ine means a triple bond. So, just like I was naming the ethenes, the alkenes, I'm going to name the alkynes exactly the same with a numbering system. Now notice that the carbons are using 3 electrons here, so they only have 1 left. This is 1 left, this is 1 left. Means I have only 1 hydrogen, and I have only 1 hydrogen. That's ethyne. And then if I have to draw hex 2-ene, this one over here, I'm going to draw my hex. 1, 2, 3, 4, 5, 6. On the second carbon, I'm going to put my double bond. So there's the first carbon, there's the second carbon. So after the second carbon, actually, let's make a bit of space here. There's my double bond. And now I'm going to put in my hydrogens. CH3, CH, because again, remember, carbon already has 2 bonds here and 1 bond here. That's 3. So I only have 1 electron left for hydrogen. This carbon has 2 electrons being used for the carbon-carbon bond, 1 for the next carbon-carbon bond. So again, it's only going to have 1 hydrogen. This one's going to have 2 hydrogens, 2 hydrogens, 3 hydrogens. Hex 2-ene. Right? So hopefully you're seeing that this is all fairly straightforward in the way that our numbering system works. Ene means I've got at least a double bond. Ine means I've got it with a Y. Y-N-E. Y-ine means I've got a triple bond. So if I look at samples on page 105, okay, so we're now getting a little bit trickier. So let's go to page 105 in the textbook here. Okay, so here's the sample problem, and it says, name the compound on the right. Okay, so if I look at this compound here, I'm seeing I've got 1, 2, 3, 4, 5 carbons with a double bond. So it's going to be pentene. And the double bond comes on either the 1, 2, third carbon or on the 1, 2 on the second carbon. So it should be a 2-ene. So it's going to be pent 2-ene. Should be pentene because it's a double bond, right? But it's got, I need to say where is the double bond, so it's after the 2 carbon. So there's pent 2-ene. And then for B here, it says draw the structural formula for 3-methyl-but-1-ine. 3-methyl-but-1-ine. Okay, so I'm seeing but is the main part, 4 carbons. Okay, I've got but-1-ine, so I've got a triple bond on the first carbon, but-1-ine. So again, let's ignore the methyl, and let's just draw but-1-ine. So I've got that right there, but-1-ine, and now I need to add a 3-methyl. Now notice that if I put it on the 1, 2, 3 carbon, because I've already started numbering from this end as 1, 2, 3, 4, I did that so that my carbon 1, my but-1-ine belongs on the first carbon. If this is the 1 carbon, I can't start numbering from the other end for the methyl. So if it's 3-methyl, I need to put on the 3 carbon a methyl group, right? On the 1, 2, 3 carbon, a methyl group. Okay, so let's erase all these numbers up here. Okay, and now I need to put in my hydrogens. The first carbon has 3 bonds, so it needs 1 hydrogen. The next carbon, okay, let's have a look here for a minute. This carbon here, it has 3 bonds here and 1 bond here. It already has 4 bonds. It doesn't need any hydrogens. All 4 of its electrons are being used, so it needs no hydrogens. This third carbon here has 1 bond to carbon, 2 bonds to carbon, 3 bonds to carbon, so it needs a hydrogen. And then my terminal carbon here has a methyl group, a CH3 group. So, what do I have? I have 3-methyl but 1-ine. Okay, so hopefully that makes sense. The textbook walks you through the drawing of all these things, right? But again, very similar to what I've done. Again, you can see there's the but 1-ine, 4 carbons with a triple bond at the beginning. And then I've got to add my 3-methyl and then put in all my hydrogens. Okay, so I'm not going any further today. I'm going to ask you to finish 9 to 16. 9 and 10 are naming, 11 to 16 are drawing. So take your time, make sure you do all this work. If you stay on top of this work, it won't get overwhelming. Okay, so I will leave you with that for tonight.